Welcome back to my YouTube channel, and now we are talking about multiplication by t, multiplication by s, division by s in inverse Laplace transform. So now we are going to move into the first shift property, which is the inverse Laplace transform of f, a function of s plus a is equals to e raised to power minus at f of t, given that the inverse Laplace transform of f of s is equals to f of t. Now let us move on. We are going to start with a simple one and one that is going to require a lot of logic or a little bit of logic for those that are already inclined. So now for the first one, we are going to be having the inverse Laplace transform of 1 over s plus 2 all raised to the power 5. Right? So now the f of s minus a is equals to e raised to the power minus at of f of t, given that f of t is equals to the inverse Laplace transform of f of s. So we can, that means this s plus a, if we assume that it is equals to s, that is, we remove the plus a, we have the inverse Laplace transform of 1 over s raised to power 5. Naturally, this is going to give us 5 minus 1 factorial over okay, 5 minus 1 factorial over t. If we look at it over here, now it's going to be t raised to power 5 minus 1 here over 5 minus 1 factorial. Yeah, so and this is going to eventually give us t raised to power 4 over 4 factorial is 4 times 3 12, 12 times 2 24 times 1 is still 24 over 24. So therefore, if we put this function, yeah, if we put it in this form, we are going to be having it as the inverse Laplace transform of 1 over s plus 2 raised to power 5 is going to be equal to e raised to power minus 2t e raised to power minus at f of t is equals to, we have t raised to power 4 all over 24. So this is going to be our final answer for this, and this is a little bit logical. So if, with a lot of practice, you are going to understand this. And now let us move on to our second question, which is this. So now moving on to our second question. So we have the inverse Laplace transform of s over s squared plus 4s plus 13. But now this is looking just like a regular odd fraction. So if we can manipulate this so that we can be able to get something like a function of s plus a, therefore we are going to be able to get an answer. So now if we look at this, how can we be able to manipulate it? For us to be able to manipulate it, we can split 13 into 4 and 9. So we are going to split this into plus 4 plus 9. That way we can be able to manipulate it, because s squared plus 4s plus 4 is equals to s plus 2 all square. So therefore we can be able to do this. Therefore we are going to have the inverse Laplace transform of s over s plus 2 all square plus 9. Now looking at this, you might think that we already have something that is similar to Cauchy, but the s function, there's still an s function here that does not have s plus 2 with it. So we have to do a little bit of manipulation for this one also to have s plus 2, because not only the denominator has to have s plus 2, the denominator also has to have s plus 2. So if we continue, we have the inverse Laplace transform of s plus 2 minus 2. We are breaking it out of nowhere because plus 2 minus 2 is 0. So we can just assume something like this, and then we have s plus 2 all square plus 9. So now let's break this down a little further. We have this as the inverse Laplace transform. So here we can put it into two places as s plus 2, which is what we need, over s plus 2 all square plus, we know that 9 is 3 square, so let's just originally put it as 3 square. Then for this, we have minus 2, this minus 2, 2 over s plus 2 all square plus 3 square. So we are going to be having this and this as p. So what we just need to do is to impute our inverse Laplace transform. So first of all, assume that this without the plus 2, without the plus 2 here, we are going to be having this as our cos. Without the plus 2, this is a plus sign, so we're going to be having it as cos 3t. But now, if we have plus 2 here, we are going to be putting our e raised power. Oh, let me just move it upward here. Yeah. Without this, we are going to be having this as cos 3t. That is, if we assume without the plus 2 that are here, then if we now put in the plus 2, we are going to be putting our e raised power minus 2t into it. That is for this. And for this one, without the plus 2, it is going to be a regular sign component here, which is equal to, here we have minus, we have our 2, then here we are going to be having 1 over 3. So that is 2 over 3, 2 over 3, then let's leave a little bit of space, and without the 2, this is going to become a sine 3t, and now with the 2, we will have e raised power minus 2t. So this here is going to be our final answer for the question that we see here in the board. So with just one or two manipulations, with a little bit of manipulation, you will always get where you want to go.